This lesson looks at why ground-air communications need to be improved in certain areas of aviation, and considers the measures which are being taken to make ground-air communications more efficient. Over and close to populated landmasses, air traffic control use radar and VHF voice communications to provide positive control over aircraft. However, over oceans, deserts and polar regions, radar is not available, and ATC provides a procedural control service. Over long ranges, communication by VHF is not possible, and the fading difficulties and static interference associated with high-frequency, or HF communication, means that ATC are often required to relay messages to aircraft crew through a third party. Without radar, ATC requires aircraft to submit position reports. For example, aircraft crossing the North Atlantic pass position reports to ATC every 10 degrees of longitude up to 70 degrees north, and every 20 degrees above 70 degrees north, which equates to a position report every 30 to 60 minutes. This means that ATC does not have positive control of aircraft, and so traffic separation has to be considerably increased. The result is a low traffic density for the airspace, and with the increase in international air traffic, this is a major limitation. There is therefore a need to increase airspace capacity, and so ATC require better communications with aircraft in regions which are currently outside positive ATC control. The aim of future air navigation systems, or FANS, is to provide an integrated air traffic control system in areas where radar is not available by using Global Navigation Satellite Systems, or GNSS, to define the aircraft position, coupled with data link communication, which we will look at shortly. FANS has been under development since around 1990. The Airbus version is known as FANS A, and the Boeing version is known as FANS 1. FANS A and FANS 1 provides a communications, navigation and surveillance system known as CNS, and an automatic dependent surveillance system known as ADS, which automatically sends aircraft surveillance data to the Air Traffic Service Unit. Communications utilize current frequency allocations in HF, VHF, and UHF L-band, and GNSS provides the navigation input for the surveillance. Currently, the system is also used by some aircraft operators to monitor the progress of the aircraft and to monitor the operation of systems on board the aircraft. A development of FANS A and FANS 1 is FANS B and FANS 2. These systems extend the data link service and are based on the principle of air traffic management using air-to-ground automation. Voice communication is reserved for emergency or non-standard communication. Using GNSS, the aircraft position is automatically reported to the Air Traffic Service Unit. Controller Pilot Data Link Communications, or CPDLC, messages to and from the aircraft are displayed on a data link control display unit, and we can see a typical message displayed on a DCDU here. Let's look next at CPDLC in a bit more detail. Controller Pilot Data Link Communications, or CPDLC, provides a specific digital link address for aircraft, and it permits data link messages to be generated for that aircraft for all stages of flight. We can see the basic elements of a CPDLC here. Ground-air data link messages have a fixed format defined within the flight management system of the aircraft and the air traffic service unit computers. The system is activated by either the pilot or the air traffic controller. Messages are annotated according to whether a response is required or not. For example, if the instruction to the pilot is to report leveling at flight level 310, then the message will remain open until the aircraft reaches flight level 310, when the FMS will send the response. No further response is required from the air traffic controller, so the response message will automatically close the message from the ground station. The message formats cover all aspects of the pre-departure clearance, taxi instructions, takeoff, climb, en route, descent, and landing. Looking again at our typical DC-DU message display, we can see an example of ATC instructions to descend to and maintain flight level 60 at the nominated descent point. Indicated airspeed is to be reduced to 250 knots. We can also see a route change, and the rate of descent is to be 2,000 feet per minute. CPDLC also has provision for voice contact requests, and lastly, emergency messages. In order to gain access to the Digital Aeronautical Telecommunications Network service, the pilot must manually log on. This is to establish an air-to-ground connection to verify if the data link communication can be performed. We will list the logging on sequence on the screen, starting with the pilot entering the 4-digit ICAO address for the Air Traffic Service Unit into the flight management system, which then sends a log-on message to the Air Traffic Service Unit. The ATSU acknowledges the log-on message and then sends a connection request message to the aircraft. The aircraft responds with a connection confirm message, and the connection process is complete. This is known as the ATS Facilities Notification, or AFN. The initial logon is carried out on first contact with the ATSU on the ground, or when entering an area with CPDLC from a non-CPDLC area, and if there has been any interruption to the service, or, in other words, if the link has been lost. Once the service is established, the equipment will carry out an automatic transfer to subsequent CPDLC-capable ATSUs. Here is a summary of the main points of the lesson. Over and close to populated landmasses, ATC use radar and VHF voice communications to provide positive control over aircraft. Over oceans, deserts and polar regions, ATC provides a procedural control service. The aim of FANS is to provide an integrated air traffic control system by using GNSS to define the aircraft position, coupled with data link communication. FANS A and FANS 1 provide a communications, navigation and surveillance system, known as CNS. FANS A and FANS 1 also provide an automatic dependent surveillance system, known as ADS. ADS automatically sends aircraft surveillance data to the Air Traffic Service Unit. FANS B and FANS 2 use air-to-ground automation. Voice communication is reserved for emergency or non-standard communication. Controller Pilot Data Link Communications, or CPDLC, provides a specific digital link address for aircraft, and it permits data link messages to be generated for that aircraft for all stages of flight. CPDLC is activated by either the pilot or the air traffic controller. CPDLC message formats cover pre-departure clearance, taxi instructions, takeoff, climb, en route, descent, and landing. CPDLC also has provision for voice contact requests and, lastly, emergency messages. Logging on establishes an air-to-ground connection to verify if the data link communication can be performed.